Hello friends, welcome to a new video. This video is going to be special because today we are not going to build another React project. In this video, you are going to learn how you can become a senior React engineer. So, if you are someone who has been learning and using React for a while, then this video is for you. In this video, you'll learn what is the difference between a junior developer and a senior React developer and how you can become one. So, what separates senior developers is not what code they write, but how they write the code. Senior React developers use certain design patterns which makes their code very simple to read, and it creates small code files which makes it easier to maintain it in the future and collaborate with other developers while working together. So, in this video, we are going to cover 8 design patterns which you can learn today and level up your skills professionally and advance in your career. Right? So, without wasting any time, let's see the first design pattern. The first design pattern in React is called the container and presentation pattern. What this pattern aims is to separate the business logic of a component from the UI logic into two different components. In this design pattern, you create a parent component and a child component. The parent component is called the container component and will house all the business logic of the component. The child component is called the presentation component and will house only the UI code for the component. The parent component will embed the child component so that together they both combine the business and UI logic. This design pattern helps to keep your code small and clean and also allows you to reuse your UI code separate from your business logic. So sometimes it may happen that your component is so large that it has a lot of business code as well as UI code. And whenever you reuse this component, although you only need to use UI at other places, you still end up importing all the business logic at all other places. So this design pattern helps you avoid such redundancies. Let's take a look at React code to better understand how this pattern works and how you can apply it. So, don't worry about understanding the entire code. There are only a few things to notice here. One, we have one component here. This component fetches some data from an API and then renders that data on the UI. Now, this component has been split into two components, the parent component and the child component. The parent component ends in a container prefix, signifying that this is the container component. The parent component also has all the code for the business logic, which includes the state, all the component state, as well as the function to fetch the API data and the use effect hook. Also notice that this container component doesn't have any UI code in itself, right? Instead, it embeds a child component which will take the data and render the UI. So now let's take a look at the child component. The character list component is the child component, and notice that there is no business logic code inside of this presentational component. It only returns the UI for the parent component to display. So this is how you can separate concerns in your React code by separating the business logic and the UI code from each other by making use of parent-child components. So to recap, container and presentation pattern helps you separate business and presentation logic. To do that, you make use of the parent-child taxonomies, and this helps you create small and concise components, resulting in cleaner code. And it allows you to reuse your UI code at other places without reusing the same business logic, right? Now let's move on to our second design pattern. The second design pattern in React is the component composition using hooks. So, like in our last example, you saw that the parent component houses all the business logic. This design pattern, component composition with hooks, suggests that you take out all of the business logic from components and put it inside of custom hooks. By doing so, no business logic will reside in the components, which will result in cleaner codes and smaller files. Let's take a look at some React code to better understand this design pattern. So, here we have a custom hook called use fetch Star Wars characters. Now all this hook does is fetches the same data by calling the same API that we saw in the parent component in our last design pattern. So instead of writing the API fetching the data and the state variable inside of the component, we remove and put it inside of a custom hook. This custom hook will take care of data fetching as well as handling all the loading states as well as all error handling as well, so that our component code becomes much more compact. So this is how our component will look after using component composition with hooks. So in the parent component, which is the container component, now you don't need to write any business logic. You only need to refer it using the custom hook that we created. So this results in smaller code files. To recap, component composition with hooks pattern allows you to isolate all the state logic into custom hooks separate from the components. It allows you to make use of custom hooks using the hooks API, which was introduced in React 16 version. This design pattern states that no business logic should reside in your components, in your React components. This results in clean code and smaller files. Now let's move on to our next design pattern. Okay. Our next design pattern is called state management with reducers. This design pattern states that you should not manage state with React components. This is because in larger code bases, a single React component can have a lot of state variables, and this increases the length of the code file. Also, it increases the pressure on the component to manage all of those state variables. To avoid this, you can remove all the state variables from a component, reducing the pressure to manage the state on the component, and place all the state using inside the use reducer hook. When you use the use reducer hook, you can manage state in Redux like fashion without using Redux locally in a component. In this way, the component doesn't directly control state. The state becomes read-only state, and whenever a component needs to update the state, they would need to dispatch an action. So to better understand this design pattern, let's take a look at a demo. So here we create some initial state, right? For example, in a component, you would need logged in, user and token state variables separately. But with use reducer, you can create a single state object which can hold all of those states, right? And then you create a reducer function which will take a state and action, and depending on what is the type of action, the reducer function updates the state. For example, if the action type is login, then the reducer logs the user in and updates all the corresponding state variables all at the same place, right? So what this leads to is that now our auth component wouldn't need to define all the state variables and manage them itself. Instead, it just needs to refer to the use reducer hook to gain access to all of those states in just one line. And this component will not be able to directly modify or mutate any state itself. Instead, whenever it needs to do so, it needs to dispatch an action with the necessary payload, just like in Redux. This ensures that your component become pure components, and all the side effect code is removed from your React components and placed inside of the separately in the use reducer hook. Right? So in this example, whenever a user submits the login form, the login function is called and a login action is dispatched with the user details, which would then go to the reducer function and the login case will be handled. And similarly, whenever the user will click on the logout button, the logout action will be dispatched and the user will be logged in. So to recap, the state management with reducers design pattern allows you to handle many states in a component without leading to any issues or burden on the component itself. It reduces the number of state variables you need to manage in your React components. It utilizes the use reducer hook and avoids using Redux for mid-sized applications. And it also allows the component, it frees the components from the responsibility of controlling its own state. Right. So far, so good. If you're still with me, you are doing great and you're leveling up so much. Now, let's move on to our next design pattern. Our next design pattern is data management with providers. So even though you haven't used this directly, you might have seen this somehow when you have installed some library in React. If you remember, then in the index.js file, you wrap your app component inside of some providers, right? So in this design pattern, you learn how you can utilize those providers yourself to write better React code. So by using providers, you avoid prop drilling, which means that you wouldn't need to pass some prop from a parent component to multiple child component, which results in messy chain of prop passing, right? This clears a lot of clutter in your code and establishes a single source of truth. And with this design pattern, your components can directly access global states without needing to depend on parent components and increasing the work required for achieving anything in your components. So let's explore this with code example. So this is how you create your own custom provider. To do so, you need to use the React Context API. First, you create a new context. So in this example, we are creating a theme provider so that you can manage light and dark modes in your React application. So first of all, you create a theme context using the React Create Context API. Then you create a theme provider component. Now all this component will do is receive children as a prop and return the children embedded within the theme context provider. Now the theme context provider, what it does is it gives access to the children, whatever the children may be, it gives them access to some value. Now in this case, the value is the state, theme and set theme variables. So what you are doing in this provider is basically you are creating a theme state variable, and you are exposing that state to all the children, right? And then what you'll do is you can wrap some component within this provider. Either you can wrap your entire app in the index.js file, or you can add certain component itself. For example, here we create a top nav component, right? And we wrap this component within the theme provider. So by doing so, the top nav component gains access to the theme state variable. So without depending on any parent component, now this top nav component can access the theme state directly using the context API with the use context hook as seen here. And so not just this component, any component you wrap within theme provider will be able to access theme state. So this avoids passing the theme state from parent to multiple children components and avoiding all that clutter in your code. So to recap, data management with providers is a design pattern which utilizes the context API. It helps you prevent prop drilling and which avoids messy parent-child chains, and it creates a single source of truth. Components in this design pattern can access global state directly with the context API. Right. If you have any doubts so far, please feel free to ask in the comments. And don't forget to like the video and subscribe to the channel. Now let's move on to the next design pattern, which is component enhancement with HOCs. If you don't know what HOCs means, it means higher order components. In this design pattern, you utilize higher order components in order to create or to add extended capabilities to your components without having to rewrite entire components with just small changes, right? So for example, sometimes it may happen that you have one component, right? Now you need to use that component at other place, but with slightly different functionality. So normally you would end up copying that entire code and creating a new component with just some small difference. You can avoid doing so by utilizing higher order components, which helps you wrap your component in a parent component and add that extra functionality that is needed. So let's take a look at an example. So you create a higher order component by creating a function. Any name can be given to that function, and this function will take a component as a parameter. This function also returns a component, a new component, as its return value. In this example, we are returning an HOC component, and this component basically itself returns the component we received in the parameter. And what the extra thing that we do is we attach some extra state to this component. In this example, we are creating a new state called name, giving it a default value, and then we are passing this name state variable to the component so that this component will have access to this state, and the rest of the props are passed as is by destructuring. So after you have created a higher order component function, the way you create new components is, for example, you have an avatar component, then you'll create a parent component by wrapping avatar component in the higher order component like this. This creates a new component called sample HOC. Now sample HOC can be used at any place in your application like this. Now Since avatar component depends on two props, one is name, the second is description. You are passing one of the prop here. Now, if you haven't wrapped your avatar component in a higher order component, then this would result in an error because you are not passing any name prop, right? If you are doing this with TypeScript, right? But with higher order component, you don't need to pass the name prop because that is injected by the higher order component. So this way you can add some extra feature to your component without having to rewrite the code for the same component, resulting in redundancy in your code base. Okay, so to recap, component enhancement with HOC's design pattern takes in a component as an argument and returns a supercharged component in which you inject with some additional data, right? Or some functionality. And this design pattern encourages composition over inheritance. It also facilitates component reuse and code sharing without having to duplicate code. Let's move on to our next design pattern, which is called compound components. So, sometimes whenever you have some large component, you can break it down into smaller components and reuse each of those smaller components independently wherever you need them. You might have seen this design pattern whenever you must have used some React component library for the UI styling, right? So let's take an example directly. For example, you are creating a toggle button, right? So in this example, first you create a toggle context using the context API. Then you create a parent toggle component. The parent toggle component will wrap its children in a provider, and that provider will expose access to some state. Now this is the state that will control the state of the toggle button, which is whether the button is on or off, and also a function that can control that state, right? Now do note that we haven't written any code for this toggle buttons UI. That is because this toggle button can have two states, which is one is the on state, the other is the off state, and apart from the on and off state, the UI needs to display a button. So instead of writing all of that code within this toggle component, you can create child components on this toggle component, making it a compound component. And to do so, what you do is you create three components called toggle on, toggle off, toggle button, and you assign them to properties on the toggle component itself. So on toggle.on, you are assigning toggle on component. On toggle.off, you are assigning toggle off, and on toggle.button, you are assigning toggle button. What this does is it will allow you to use these components like this. So whenever you need to use the toggle component, you'll first use the wrapper, the parent, the compound toggle component, right? This is the compound component. This is compound because it has some child components like this. So then on the toggle component itself, you have some sub components like toggle.on, toggle.off, right? So let's take an example of the first one. In this case, toggle.on, and it says the button is on. So that text, the button is on, will be passed as children to this component, right? And here this component will check whether on is true or false. Now what is on? On is nothing but this state variable which was exposed to toggle.on using the context API. So initially on is false, so this condition will become false and children will not be displayed, rather null will be displayed, right? So which means that toggle.on is null, so the button is on will not be displayed. The button is off will be displayed instead, right? and the button is off will be displayed, and the toggle button will also be displayed like this. So this is how you create compound components which you can reuse in other parts of your app independently from each other. Let's move on to our next design pattern, which is called prop combination. So many times it may happen that from a parent component, you need to pass a large number of state variables as props to your child component. This results in, or you can say, a wide line of code which extends your screen, or a single component reference which extends multiple lines. This makes it harder to read and can easily be avoided by using the prop combination design pattern. So in this design pattern, you combine all of your props into a single parent object and then pass that single parent object as a single prop to a child component. Let's take a look at an example. So in this case, we have a component called P, which receives some props, right? And the props are color, size, and children, and maybe a bit more, right? So in order to embed this component in your app component, you need to pass all these props here. And if in this case there are only 3 props, but let's say that there were 100 or 200 props, so that might clutter your code a lot. To avoid that, you can create a single object and put all of your props inside of this object and pass that object as a prop. This makes the code more readable and clears the clutter in your code. Right. Next design pattern, or before that, to recap, prop combination. With prop combination, you create a single object out of several related props. You pass it as a single prop to child components. This results in clean code. It also makes it simple to manage the props. It creates reusable and versatile components, and this helps you avoid passing lots of props, especially when you have a large chain of parent-child chains, right? Now our next design pattern is called controlled input design pattern. This is a very basic React, some concept that you learn at the beginning when you start learning React. But you need to understand why this is such an important concept. So in React, you use something called one-way data binding, which means data can only flow in one direction. But the default input tags that you use in HTML introduces two-way data binding if you use them directly in React. To avoid using that, you make those input fields into controlled input fields, and that way you forcibly make those input fields follow one-way data binding. To do so, what you do is you attach an event handler to an input field which will update some state variable, and that input field can only have the value of that state variable. This makes the input field a controlled input field, right? Let's take an example. Say you have an input that accepts some value. So to make it a controlled input, you pass a value which is a state variable, and whenever the input is changed, you change the state variable which was passed to the input. So this way there is only one-way data binding, and this makes your component a controlled component, right? So these were all the advanced design patterns in React, which if you follow will make you a senior React developer and will help you write better React code and level up your career. If you like this video, please subscribe to the channel. It motivates me to create more content for you. Please comment what kind of content you would want to see on this channel as well. And I'll see you next time. Hope you like this video.